We are talking about simplifying radicals, and we want to use conjugate pairs to simplify radicals. So here we have 4 divided by 5 minus the square root of 2. And the issue here is we have a radical in the denominator, but we also have the operation of subtraction. So that's where our conjugate pairs come into play. So what I'm going to do is I'm going to write down the original expression, which is 4 divided by 5 minus the square root of 2. And now I'm going to multiply the denominator by the conjugate pair. So the conjugate pair means keep the terms the same on the outside and change the sign. So in order to make sure that I don't change the value of this expression, I have to multiply by 1. In order to make this 1, I just multiply by the same thing. So when I go and do this multiplication in the numerator, I just multiply 4 times both terms. So 4 times 5 is 20. And 4 times the square root of 2 is 4 square root of 2. Then in the denominator, I'm going to take 5 times 5, which is going to be 25. And I'm going to say 5 times the square root of 2, which is going to be plus 5 square root of 2. Then I'm going to take the negative square root of 2 times 5, which is going to be negative square root of 2, well, negative 5 square root of 2. And then negative square root of 2 times the square root of 2, and that is negative the square root of 4. So now in the numerator right now, I can't reduce that, but I can reduce the denominator. So what happens is 5 square root of 2 positive cancels 5 square root of 2 negative, that drops out. And I know that the square root of 4 is 2. So I can write this down as 2 or 20 plus 4 square root of 2 divided by 25, and then minus the square root of 4 is 2, so minus 2. And what that ends up being is we can't reduce anything in the numerator, so that's just going to stay 20 plus 4 square root of 2, and 25 minus 2 is 23. Now in the numerator, we can factor out a 4 if we want. Either one of these will be fine. So if you factor a 4 out, we can get a 4 on the outside multiplied by 5 plus the square root of 2, all divided by 23. And either one of these will be fine. The next one we have is the square root of 3 divided by 2 minus 3 square root of 2. And we're going to do the same process. So the first thing I'm going to start with is I'm going to write down the expression, which is 3 divided by 2 minus 3 square root of 2. And I'm going to multiply by the conjugate pair. Which is going to be keep the outside terms the same, change the sign, and in order to make sure we don't change the value, we want to multiply by 1. So to make this 1, we just make it be the exact same as the denominator. Then we just have to distribute and multiply these together. So the first thing, 3 times 2 is 6. And 3 times 3 square root of 2 is 9 square root of 2. Then we can take 2 times 2 is 4. 2 times 3 square root of 2 is positive 6 square root of 2. Then we can take negative 3 square root of 2 and multiply it by 2. So we get negative 6 square root of 2. And then negative 3 times the square root of 2, we multiply that together, and we get negative 9 times the square root of 4. Okay. Now if we do this correctly with the conjugate pair, always the middle term should drop out, and that ends up getting rid of our radical. So then we can rewrite that. We can't do anything with the numerator, so we're just going to leave it as 6 plus 9 square root of 2. We can bring the 4 down, and we say plus. We know what the square root of 4 is. The square root of 4 is 2. So it'll be plus, well, that's the plus sign, but then this is minus, so minus 9 times 2. And that is going to be equal to, this is negative 18 plus 4, so this ends up being negative 14 in the denominator. And then we have 6 plus 9 square root of 2. And in the numerator, we can also factor out a 3. And we could have in the numerator 3 times 2 plus 3 square root of 2. And then still over negative 14. But we don't like a negative in the denominator. So what we can do is we can put that negative up top with the 3. And then this will be the final answer for that one.